ಕ್ಲಾಸ್ ಅಷ್ಟೊತ್ತಿಂದ ಫೋನ್ ಬರ್ತಾನೆ ಇದೆ, 10 ಕಾಲ ಆಗ್ತಾನೆ ಇಲ್ಲ ಕ್ಲಾಸ್ಗೆ.
ಸತ್ಯನಾರಾಯಣ ಸರ್ ಬಂದು ಕಳ್ಸಿದ್ರ ಅವ್ರು ಬೇಗ ಕಳ್ಸಿದಾರೆ, ಇವತ್ತೇ ಕಳಿಸ್ಬೇಕು ಅಂತ. ಫೋನೇ ಮಾಡೋದು ಬೇಡ ಮ್ಯಾಮ್, ಗೊತ್ತಿದೆಯಲ್ಲ ನಿಮ್ಗೆ ಹೇಳಿರ್ತಾರೆ.
ಇಲ್ಲ ಮಾಡಿಲ್ಲ. So good morning students. Today I am going to start the 4th module. So in 4th module you are going to study about the test execution. Next you are going to study about the process framework and planning and monitoring the process. So in test execution you are going to study about the overview of test execution, how we are executing the test cases and how to construct the test cases and forming the test suite, and how important the test cases are, whether those test cases are general test cases or the specific test cases that you are going to study. After that you are going to study about test oracles, self checks as oracles, and next you are going to study about the capture and replay. So these things you are going to study in the test execution chapter, that is the 17th chapter from the second textbook. So second textbook, as you know, it is software testing and analysis, process principles and techniques by Maro Feze and Michael Yang, same textbook. Okay, so in that textbook it is the 17th chapter. So you're going to study the test execution in the 17th chapter, and in 20th chapter you're going to study about the process framework, planning and monitoring the process, that is the chapter 20. So once I complete this chapter 17, then I'll move on to the chapter 20 for process framework, planning and monitoring the process. So first I'll start with the test execution. So in this, as I said, in this chapter, you're going to study about what is the test execution, why do we require the test execution. Next, you're going to study about the test cases, whether the test cases are the specific test cases or the general test cases that you are going to study. Then you're going to study about the testing oracles. Okay, these things you are going to study in this chapter. So first we'll start with the execution. So as you know that once the system is implemented, what is the next step? You have to test the implemented program or the implemented system, right? So why you are going for execution of the test cases? See, in order to identify the faults or the errors which occur in the implemented system or in the implemented program, we are going for testing. Testing means you're testing the implemented system or the program by using different test cases, where these test cases are present in the test suite, are present in the form of test suite. Okay, understood what is test suite? Test suite consisting of set of test cases. Okay, these test cases we are applying on the implemented system or in the implemented program in order to identify the faults or the errors. So to perform the testing, different tools are available, or the testing is supported by different tools. And test execution must be efficiently automated for frequent re-execution without the human intervention, because we have to perform the testing continuously on the implemented system or the program, and hence the testing must be automated. Automated means there is no intervention of the human, so we are using the tools for the testing, so those tools are automatically applied on the implemented program or the system to test the developed or the implemented program or the system, right? So testing should be efficiently automated for continuous re-execution of the different test cases without human intervention. So why we have to go for automated testing? Why we are not using any human intervention? Because humans are slow, and when the humans are involved in the testing and they are verifying the results, there may be a chances that the human faults occurs. So in order to avoid that, we have to perform the testing automatically. Our automated tools must be used in order to perform the testing. So as you know that designing the test cases and the test suite is a creative activity. So like any design activity, testing is also a creative activity, and it requires or it demands for the intellectual activity and requiring the human judgment only during the construction or designing of the test cases or the test suits. Only during that time we need the help of the humans. Once the test cases or the test suits are designed and developed, then applying those test cases and performing that test execution should be automatic one. Because see here, executing test cases should be automatic. Why? Because once we design the test cases or develop the test cases, these test cases are going to be executed many times. And why we are going for the automated one? So because if humans are involved, then the system or test execution becomes slow, and there may be a chance that human error occurs. So in order to avoid that, we are going for automation of the testing process. So test automation separates the creative human process from the mechanical process of test execution. So here, once we automate the testing process, so it separates the human process from the mechanical process of test execution. So automation automatically takes place and test execution takes place without any human intervention. So next, the overview of the test execution. As we know that we need to construct the test cases and we need to construct the test suits. As we know, it is a creative activity, and executing those test cases once they are constructed should be mechanical, as compiling the latest version of the product. Means it should be a mechanical process, and it should not involve any human work or human, right? And so once the product is developed, and it is not treated as complete product until it passes the test execution process, or until it passes the testing process. Understood? So suppose let us consider that you have implemented one program, and we cannot say that that is the complete program until that program satisfies the testing process, or we are applying the different test cases on the implemented program. Once that program gives the correct results for the different test cases, then only we say that the program implemented program is a complete program, otherwise it is not. So the implemented product or the implemented program is considered to be the complete only when it completes the or only when it passes the testing. Okay. As we know that we need the testing, and the purpose of runtime support for testing is to enable frequent and free re-execution of a test suite, and a large test suite of test data may be generated automatically. So here, if you want more number of test cases or large test suite, then those test suites are going to be generated automatically, and it includes the more compact and abstract set of test case specifications. So once it is done automatically, then it includes more compact and abstract set of test specifications. And so we can use these test cases or the test suites for the unit testing, and for also integration testing, and sometimes these test cases may also used for the whole system testing. Okay, so obtained test cases or the designed test cases or test suites can be used in unit testing, integration testing, as well as in sometimes we can also use it for the system testing. And whenever we are testing the implemented software, that may be combined with the additional scaffolding code to provide the suitable test environment. So then what is a scaffolding code? So scaffolding code is nothing but the additional code developed to uh, 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 to facilitate the testing is called as the scaffolding. Okay, so here we are testing the implemented software or the implemented program or the implemented system, we can say. Okay, when we are testing that, we are using the scaffolding technique, means we are using the additional code in order to what help the testing process, or in order to improve the testing process, we are using the scaffold test coding technique. So scaffolding is nothing but using the additional coding for the testing process. So once the test cases are designed and developed, whether these test cases are the specific test cases or the general test cases, okay, that we need to consider. Okay, so uh, so once we need to construct the test cases or the test suites, we have to check whether they are applicable to the general systems or to the specific one, or specific to a software, or specific to a particular program, that we have to decide. So first we'll see the generation of the test cases from the specifications. So uh, so if the test case specifications produced in the test design, which already includes the concrete input values and the expected results, right? So what this test case consisting of, that you have studied in the first chapter itself. So whenever we are designing or develop the test cases, these test cases includes the concrete input values, or it includes the input values as well as the expected output results. So without the input and the output result, we cannot say it is a test case. So whenever the test case is designed or it is developed, or test cases are constructed, these test cases must include the input as well as the expected output result. And so these type of test cases can be used by using the category partition method. Then once we use the category partition method, we can perform the complete testing on the developed system or on the developed program. Then, so producing the complete test case may be a simple one, or it may be a very complex task. Okay, so it may be very simple, means just as filling some forms. Okay, if I ask to fill some form like your name, then university seat number, and your previous semester results, or 10th result, or PUC result, it is just like that. Means producing the complete test case is as simple as just filling the form, or it may be the complex case when we are constructing the test cases for the complex systems or for the entire developed software, then it may be a very complex task. So next, a test design often yields test case specifications rather than the concrete data. So here in the testing process, the first step is we have to design the test cases, right? So how we are designing the test cases? We are designing the test cases from the given specifications, right? So test design results in the test case specifications rather than the concrete data. For example, here they given a large positive number. The positive number may be any number which is ranging from 0 to some maximum value. So then here we are not giving any particular number, because the positive number means it may be ranging from any value from 0 to any larger positive number, right? So there we are not particularly specifying which positive number, right? So if we are specifying it as a number, particular number, just like this 420023, then we say that it is the concrete data. But here we are specifying it as a large positive number, then the number may be any number, but it is a very large number. We are not specifically telling that, right? Next is a sorted sequence. Length we are giving, so length may be 2 or 2 power n, it may be anything, right? So here we are not specifying the particular value for that length. So then we say that it is a test case specifications rather than the concrete data. So when we say that it is a concrete data, one particular value is assigned for that, then we say that it is the concrete data, otherwise it is not. And other details for execution may be omitted or may be left over, and generation creates concrete executable test cases from test case specifications. So here once the test case specifications is given, then we can generate or the creates the concrete one and the executable test cases from the test case specifications. So one example here they have given, but it is not there in your textbook. We can just go through this. So one example is the tool chain for test case generation and execution. So it is a combinatorial test case generation to create the test data, and here the options is constraint based data generator to concretize individual values. For example, the positive numbers to 42. So like that we can have the different test cases for the given specifications, and DD steps to convert from spreadsheet data to JUnit test cases, or JUnit to execute concrete test cases, or many other tool chains are possible. So like that for the given specification test specifications, we can construct or develop different design cases. Next, we'll go for scaffolding. As I said, whenever we are performing the testing process, we can make use of the scaffolding. So scaffolding is nothing but the code which is developed or produced to support the development activities, or here especially in case of testing. So code produced or developed to support the testing activities is called as scaffolding. Understood? So in the exam, they may ask what is scaffolding, and explain the technique for the testing process. So we have to explain what is a scaffolding. Code which is developed or produced in order to support the testing activity is called as the scaffolding technique. And this code, whatever we developed, which is additional one, is not part of the product as seen by the end user. Okay, so this code only developed for supporting or encouraging the testing process, or we in order to not part of the product or the implemented program. Is it clear? Scaffolding, it program, and this code may be temporary code only for testing that particular software or the program. So it includes scaffolding includes the test harness, drivers, and the steps. And what is the purpose of using the scaffolding? The purposes of scaffolding are to provide the controllability to execute the test cases and observability to judge the outcome of the test execution. Is it there? Okay. So the main purpose of using the or developing the scaffolding code is to control the execution of the test cases. Okay, is to provide the controllability to test cases and observability to judge the outcome of the test execution. Okay, understood? In order to control, in order to provide the controllability to execute the test cases and observability to judge the outcome of the test execution. So because see here, once the system is developed and so many number of test cases are developed, and these test cases we need to employ on the implemented program. So in order to control which test cases to be applied on the implemented program, we are making use of the scaffolding technique. Okay, so and in once you applied the test case, then you are getting the output, right? And to judge the obtained output, whether the obtained output is meeting the user specification or whether it is according to the expected result or not. In order to judge that, we are using the scaffolding technique. Understood? So scaffolding, it is the additional code developed or produced to support the testing activity. Clear? Understood? Next, why we are going, or what is the main purpose of using this scaffolding technique? In order to provide the controllability to execute the test cases and observability to judge the obtained output result, we are using the scaffold technique. And sometimes scaffolding is required to simply make a module executable. So suppose the system consisting of different modules. In order to execute a particular module, we are making use of the scaffolding technique. Understood? So scaffolding is used in order to make the module execution, because so many modules will be there in the program. In order to execute a particular module, we are making use of the scaffolding technique. And here, as I said, this scaffolding technique may be the test harness, or it may be the drivers or steps. Drivers means, as you know, that we are using the additional code in order to run a particular one. So best example is whenever you are for your laptop or systems, whenever you are connecting the external devices like printer, then once you connect the printer to the laptop, it is not automatically running, or it is not going to automatically print the pages. So what you have to do, you have to install the printer in your system. How we are installing the printer in your system? By using the device driver. So there exists a device driver for the printer. Once you install that device driver in your system or laptop, then only you can make use of the printer to print the pages. Like that, the scaffolding is an additional code. So it helps us in running the particular module or running the entire program. Is it clear now? Understood? So like that, we have the steps and also the test harness. So one more example is an interactive program that is normally driven through a graphical user interface. So then in order to drive that system through the graphical user interface, or in order to run that program through the graphical user interface, then we need the drivers or other steps or the harness of programs. Okay. So here we have the test driver, test stubs, and the test harness. So what is a test driver? As I said, it is some program, a main program for running a test. So it is just like, as I said, when you are connecting the printer, then to run the printer, we need the program. So that is exist in the form of a drivers. So but if you consider with the testing, so we have the test driver, a main program for running a test. It may be produced before a real main program, and it provides more control than the real main program. And here, by using this, to drive the program under the test through test cases. So these are the usage of the test drivers. So it may be a main program or it may be produced before a real main program. And when we're using the test drivers, it provides the more control over the real main program. And the test steps are nothing but these are the additional programs substitute for called functions, methods, or the objects. As you know that when you implemented a larger program, those programs consisting of different functions, methods, objects, or even the procedures. So when you're calling the function or the method or the object or the procedure, we are making use of the test steps. These test steps are nothing but the scaffolding technique. Okay. So scaffolding technique is nothing but using the additional code in order to call the functions or call the procedures, methods, or the objects. Understood? Next, we have the test harness. It substitutes for other parts of the deployed environment. So, for example, software simulation of a hardware device. So, if you want to know this, how the system operates through the simulator, then we can make use of the software simulation, and that is nothing but the test harness. So as I said, through the scaffolding, we are providing the controllability and the observability. So here one example is given for the graphical user interface input. So that we are using in order to perform the different functions. And we are providing the, or it once that particular program is executed, we are getting the output. So the best example for this is in Windows operating system, we are using the different icons. So Windows operating system mainly implemented by using the graphical user interface. So in the graphical user interface, what happens? Each one is represented in the form of a icons. Then by just by using the mouse pointer, you can directly click on that, then that particular will be open and you can execute. So the best example is your calculator, which is present in your Windows operating system, right? So if you want to calculate something, what you are going to do, you are simply opening the calculator, then you are clicking the values, and you are getting the result. So there you're using the graphical user interface in order to perform the uh, uh, different functions or different operations, right? So once you perform the different functions or operations, what happens? You are getting the output. Once again, the output is it is in the form of a graphical through the graphical user interface. Means you are getting the graphical output. So one more example, they give an MVC controller and the output will be in the form of MVC view. So here, so what we want the automated test, but interactive input provides the limited control and graphical output provides the limited observability. So that is required, and this is done through the scaffolding technique. So one more they are given through this. Here we are, along with the program functionality, we are using the application programming interface. APIs are used. See here. So a design for automated test includes the provide interfaces for the control API and observation on wrapper and the output. So here in with the help of the API and the capture wrapper, we are providing the output, and the API it controls the testing of the given system or the program. And once the test cases are generated, we need to know whether those test cases are the general one or the specific one. Our test cases are, if we consider in case of the scaffolding, means the developed additional code, whether those codes are the specific one or the generic one. So first question we have to answer is how general should be scaffolding be? Means that scaffolding code that we have produced, whether that is suitable for running all the programs or testing all the programs or only for a particular one, that we need to know. And here we could build a driver and the steps for each test case. So we have the test cases. For to run those test cases, either we can make use of the drivers or the steps. So if we build the drivers or the steps for a particular test case, what happens? So since to test the implemented program or the system, we have so many number of test cases, right? And if we are developing a driver for each test case, then what happens? We need to develop more number of drivers or the steps for each test case. But that is not useful, because that leads to more number of additional code, right? So then we have to avoid such type of drivers or steps, or we have to avoid such type of scaffolding technique, and we have to go for the general one, so that most of the test cases can be tested for on the given system or on the implemented program. Okay, so we could build a driver and steps for each test case, or at least factor out some common code of the driver and the test management. For example, they have given the J unit. So in that, uh, so so instead of developing the driver or the steps for each test case, we are identifying the common code which is common for all the test cases, so that we can make use of those common code for those test cases, so that we can easily test the implemented program. So here that is the case, or at least factor out some common code of the driver and test management, or support further factor out some common support code to drive a large number of test cases from data, or further generate the data automatically from a more abstract model, for example the network traffic model. So we are going for the generic space scaffolding, or the generic drivers and steps rather than the specific one. Why? Because as I said, if we are developing a specific driver or the steps for each test case, what happens in to test the program or to test the entire developed software, more number of or vast number of test cases are designed. So if we are using a separate driver or the stub for each test case, then it results in vast number of drivers or vast number of steps. Then what happens? It increases the complexity of the testing process, and the cost also increases, because it requires more time for using the particular code to test the particular test case. So more time is required. So to avoid that, what we can do, we can make the general code which is the common code for the driver and the test management, or which is the common support code for driving the larger number of test cases, or it is the uh, common code which generate the data automatically from a more abstract model. Understood? So rather than developing a specific driver or the specific step or the specific scaffolding code, we have to go for the general code, so that we can minimize the time required to test the system, and as well as the cost also decreases when we are going for the general scaffolding technique or general drivers or steps. Because here a question of cost and the reuse exists, because if we are specific to a very particular test case, then that driver or the step cannot be reused. Okay, if it is not reused, then the cost increases. Hence, in order to reduce the cost and in order to reuse the existing drivers or the steps, we have to go for the general one rather than the specific uh, drivers or the steps, are rather than developing a specific scaffolding code. So this is about the scaffolding, and whether the scaffolding is a generic one or the specific one. So in the next class, you are going to study about the oracles. So what are oracles? What are the test oracles? How they are useful in testing the process? That you are going to study in the next class. Along with that, you are studying the comparison based oracle and self-checking oracle. That we'll see it in the next class. Understood? Any doubt in the test execution? Yes, Sharanya, Sachin.
No, ma'am.
Any doubt? Any doubt?
No, ma'am.
Understood what is test execution and what is a scaffolding technique, and the generic and the specific scaffolding technique. If you have any doubt, you can ask now. Any doubt?
No.
If you have no doubt, then